Hi, my name is Adric Riedel, and I'm here to talk about a topic that's gained some notoriety: the Death Star, and how it might destroy the Earth. Now, I know what you're thinking, and actually that's not a space station, that's a moon of Saturn. What I'm actually talking about is stars destroying the Earth, and I don't actually mean that they'd crash into each other, because this basically never happens. Instead, I'm talking about asteroids. You may remember asteroid collisions from the Earth from 65 million years ago, when they wiped out nearly all of the dinosaurs, or from the hit blockbuster movie, or from another recent hit blockbuster movie, or from 2013, when a large chunk of something burst through the skies of Siberia and startled a lot of Russians. Basically, asteroids are everywhere, and they frequently hit the Earth. You can find when the next asteroid passing near the Earth will come if you take a look at this web address. Sometimes there are 4 on any given day. Granted, they're not the ones hitting us for the most part, but there are a lot of them out there. How does this involve other stars? Well, if you look at interstellar space, you have the Sun. Alpha Centauri is the closest star system, but they're pretty far apart. 4.2 light years is a long way. Except that the solar system is actually pretty big. Surrounding the Sun at very large distances are a cloud of ice balls that form the Oort cloud. There's millions of them. They possibly stretch about a light year from the Sun. They're basically barely gravitationally bound to the Sun at all, but they're there, and if anything stirs them up, they can turn into comets as soon as they get close enough to the Sun to start to melt. The general idea of where a star could come into this is if a star happens to pass close enough, it could knock one of those icy bodies into the inner solar system, where, if we were extremely unlucky, it could score one of the most unlikely jackpots of all time and hit the planet. The first idea of how this could possibly happen came about in the mid-'80s when people were looking at mass extinctions, and the idea was that the Sun was actually a binary star system. They're pretty common, so it wasn't unreasonable. The idea is the companion would be a tiny star, or a brown dwarf, which is between a star and a planet, in an incredibly long orbit that once every 25, 35 million years would swing out into the Oort cloud, send a swarm of comets into the inner solar system, and basically put us in a gigantic game of lethal pinball. Unfortunately, or fortunately, we've never seen anything like that. There's no signs of a gravitational influence of anything out there, and at this point we're pretty sure that we would have seen it. We have lots of observations of the entire sky that should be able to detect a red dwarf or brown dwarf. It's just not there. And this also goes for the other way that this particular theory lives on, which is, if you've ever heard of strange internet theories, there's Nibiru, which is supposed to be a planet that will pass so close to Earth it'll knock the planet from its axis and destroy it. Suffice to say, this didn't happen, and Nibiru does not exist, and we would know if it did. So what is going to cause a star to stir up the Oort cloud? Well, the prevailing theory at the moment is that it's actually just other stars orbiting the center of the galaxy. They're all on their own particular orbits as they swing around, and some of them will end up passing close enough that they will make some sort of a stir in the Oort cloud. The topic that I'm most interested in, and the particularly notorious object I'm going to talk about, is Hipparchus 85605, which is that one. It's the dimmer of the pair. The fact that it's a pair will be important later. It's also got some other names, but suffice to say, this is the Death Star, reported by Corin Baylor-Jones. He did a large simulation of stars and orbits and found out that this particular object would potentially pass within 0.04 parsecs of the Sun. That sounds like a really small distance. It's actually still pretty far. If the distance from the Earth to the Sun is 1 AU and Neptune is 30 AU, this is more like 8,000 AU. But that's still very, very close and would potentially have stirred up a whole lot of stuff and sent a whole bunch of comets near the Sun. But if you're going to prophesize doom for the entire solar system, it kind of makes sense to make sure that you've done your math correctly. And what that means is that you need to make sure that all of your data is correct. So, if you're looking at a star, you need to know where it is, how far away it is on the sky, and basically the direction that it's moving. Once you have all of those things, you can trace its position and figure out where it's going to be at any point in time, and that's kind of where this all starts to fall apart, because of an interesting quirk of the way that stars exist. You may be familiar with the HR diagram, which is essentially a diagram showing the relationship between the temperatures of stars, which you can see here, the famous spectral types O, B, A, F, G, K, and M, which go from hottest to coldest. Well, if you plot them against how bright they are, you find out the O stars are the hottest and by far the brightest, and actually the largest, and the little guys are small, but at least they're numerous. There are also giants, and those are stars at the end of their lives. They've run out of hydrogen to fuse, so they're kind of expanding outwards. They're in their death throes. The ones that are actually going to do really interesting things, though, are the supergiants. Those are the ones that explode in, supernovas and leave behind white dwarfs and things like that. The point of the HR diagram, though, is that all known stars should lie somewhere in simple, recognizable patches of this diagram. Anywhere that you don't see anything here, there's pretty much not going to be any other stars. So the problem was that if you used the distance that Corin Baylor-Jones got, with good reason, if you use that distance, you find out that his star was supposed to be down there, which means it would be unusually dim, and there's no other stars like it. If you try to fix it so that it would be a normal star, it ends up being much, much farther away. And, of course, if the star is much, much farther away, it turns out it comes nowhere near us. So how did the measurement problem happen? How did this distance problem come about? Well, turns out it's a particular quirk of the instrument that measured the distance. If you have a binary that's the right distance apart, the system tends to screw up. It uses a grid, and it watches basically just the light levels as it watches the sky and stars pass behind the grid. And if you happen to be exactly the right separation, both stars pass behind the grid at exactly the same time, and it can't tell them apart. And what basically happened is when it came time to match up all the observations, it kinda screwed up which one was which ended up producing a star that appeared to be incredibly close all of its data was wrong because it was mismatched. Now, Corrin Baylor-Jones knew about this possibility, talked to somebody who was an expert on this instrument, and was told that this result was okay, that it was real. I don't think it is, because of the HR diagram and just the general known problem with these stars, but, the guy's forgotten more than I'll ever know about this topic, so who knows. But for now, I think the safest bet is to say that the next close approach of a star to the solar system is this guy, Gliese 710, which has been noticed and known for years and years to be coming very close to us, although not quite as close as Hipparchus 85605. Of course, that's in 1.3 million years, so you don't need to worry about that just yet. I would note that a lot of the considerations I just mentioned were actually put into a scientific paper by Eric Mamajek, who pointed out and rigorously defined all of those things I just said and essentially proved that Hipparchus 85605 isn't going to come near us. He did suggest another object, which you see here, called Scholz's star, that probably passed close to us about 70,000 years ago. Again, not quite that close, but it's possible that it might have stirred something up, so you never know. The next bright comet you see might be the result of that close pass 70,000 years ago. What can I say? Space is a fascinating place, and it has many ways that it tries to kill us.